This is the first video for energy, work, and power. Work is the transfer of energy by applying a force causing the object to move. If the object does not move, no work is done. Okay, there's always going to be a question on your quiz or your test or your SLO that says, so a boy or a person is pushing something that is very heavy. It does not move. How much work is done? If nothing moves, no work is done. This is really, really, really important. See, I'm like drawing a box around it because it's so important. Okay, work is measured in joules. And the way I like to remember it is that you have to do a lot of work in order to be able to afford joules. That's kind of lame, but it gets the point across. Hockey puck and it's sliding across the ice, and a player is exerting a constant 4.5 Newton force over a distance of 0.15 meters. And we want to know how much work the player does on the puck. So the first thing we need to do is we need to go ahead and we need to write all of the things that we know. So the first thing that we know is that our mass is 105 grams. Okay, now whenever we do math problems, we can't leave stuff in grams. We always want to move it to kilograms. So I'm just going to do a little conversion here, and I'm going to write it right here so I've got it all ready to go. And we know that there's 1,000 grams in 1 kilogram. So I'm going to have 0.105 kilograms as my actual mass that I'm going to use in the math problem. Okay, and then we have a force of 4.5 newtons. So we can write that down as something that we know. And then they also gave us a distance of 0.15 meters. Okay, and so they want us to find the work. Okay, we have these grams, we have these newtons, we have these distances, and they want us to find the work. So our work formula is just work equals force times distance. And so you can see that we don't even need that m they gave us. They totally gave us that just to throw us off, and we don't even need that. So we can actually go ahead and cross it out if you want, if it makes you feel better. Okay, because all we need is the force and the distance. So then we can just take our force, 4.5 newtons, multiply it by 0.15 meters, and that's all you do. Now let's look at work done at an angle. If work is done at an angle, you're going to have be given an angle in the problem, and then your work formula will become force times distance, which we already had, and then you'll have this cosine theta, and your angle will go in the theta section. So let's try one of these. In this problem, we have a sailor pulling a boat a distance of 30 meters along a dock using a rope that makes a 25-degree angle with the horizontal. How much work does the sailor do on the boat if he exerts a force of 255 newtons? So let's write what we know. We have a distance equal to 30 meters. We have an angle equal to 25 degrees. They're asking us for work, which is in joules, and then they give us a force of 255 newtons. Okay, now our formula for this is work is equal to force times distance times cosine theta. Since we're looking for work, we don't have to do any algebra. We can go ahead and just plug our numbers in. When I do these problems, I usually go ahead and I find the cosine first. So I put that in the calculator and I got 0.99. Now I'm going to multiply all three of these things together and I should get 7582.70 joules. And that's how you solve work at an angle problems. They're not that much difficult than regular work problems.